All right, U substitution. Let's do another example. This one is maybe going to look a little bit harder than what we've been working with, but hey, it's not that hard.
That was easy.
See, that's what we're going to be able to say here when we're done. All right? You guys love that, don't you? Okay, so this is, I mean, super complex here, right? Really ugly looking. Not sure how we're going to do that, but let's think about U substitution. Now, what would be a good candidate for being U? Something that's deep within sort of this function here. Okay, yeah, good. Now that's a good place to start, okay? Because that is deep within the function, right? It's in the denominator. It's underneath the root sign, okay? What else would maybe confirm in our minds that we may have the proper function to set equal to U? What else? What else would indicate that this is a good choice for you and me? Thank you. Yes, the derivative, the du, is negative 3x squared dx. Now, do you see a negative 3x or an x squared or anything like that in the integral? Doo, doo, doo. Voila! Right there. Thank you for saying that so loud. Yeah, it's almost like there's a real classroom going on here. Appreciate that. Yeah, magic Saturday. Okay, so this is good. This is du, pretty close to du. Close, right? Right here. So, here we have u and du. Okay? Now, I have x squared dx here, so what am I missing from this integral? A negative 3, okay? So let's just say, I'm going to do 1 over the square root of 1 minus x cubed, and we'll come back to this in a second. I have x squared dx, okay? Okay? I need a negative 3, so let's put a negative 3. You can put it anywhere. Just don't have room over here, so negative 3. I'm going to have to put a negative 1/3 outside, right? Because remember, it has to be, whatever I do here, it has to multiply to 1. So if I put a negative 3 in there, I have to put a negative 1/3. Negative is positive, 1/3 times 3 is 1. Okay? Now I look at this part right here, and I say to myself, okay, can I simplify this any? Well, let's do our U substitution and see what happens. So I have negative 1/3, and I have the integral of, okay, so I have 1 over the square root of u, du. Notice that du is there. 1 over root u. Okay, you guys okay? You okay with that? Again, that's 85, 90% of the whole thing. Getting that right. Now, this right here, do we have an integral or an antiderivative for 1 over root u? 1 over root u? Or shall we, change how it looks somehow? What if we went negative 1/3 times the integral of, what is this written a different way? U to the negative 1/2, yeah. I would concur. Okay. Now, can we take the antiderivative of this? Yeah, just a variable to a power, right? So that is going to be fairly simply dimply. Right? So we got negative 1/3. And this, now that we're actually integrating, can be dropped because we have u and we have u. We're good to go. So we add 1 to get u to the positive 1/2. And then I do 1 over 1/2, which is really times 2 here, plus c. Is that looking okay so far? Which simplifies to negative 2/3 u to the 1/2 plus c. Or when I make my substitution back again, I get minus x cubed. Oh, that's a cube. To the power of 1/2, or honestly, you might want to just write it like this as well. Right? To the power of 1/2, just do root. Doesn't matter. Okay? So there you go. Questions? So if we take a look at an example for an indefinite integral, watch this if you want. You can work on your assignment there if you want to keep going. But if we have e to the power of 2x plus 1 dx, then what we want to do again is take a look at this, and I have definitely two functions. I have 2x plus 1, and I have e to the x, right? Two functions. So u is going to be sort of the inner function, which appears to be 2x plus 1. Du is 2 dx. And all I need is a 2 in there, so that's no problem. Put a 2 in there as long as I put a 1/2 out here. All right, so now I can do my U substitution. And this is e to the power of u, and don't forget the 1/2 there, eu du. Okay? And when we integrate, that's going to be, well, I guess the antiderivative of e to the u is just e to the u. This is gone and this is gone. And I'm going to make sure you put remember to evaluate there, right? So if we evaluate this, we've got 1/2 e to the 1 minus 1/2 e to the power of 0. And so if we simplify that, we can take out 1/2, and that's going to be e minus 1. Do that right? 0 and 1. All right, so actually got to back up here, and the one thing that I forgot to do here, and this is the change in the definite integral, is if it's 0 to 1 for this function, when you change u here, first of all, we got to sub this back in, or we change the limits of integration. So yeah, so what I didn't do was substitute u back in before I did this. So again, there's two different ways you could go. You could change the limits of integration here by plugging 0 in for x, right, and getting the lower limit, and then 1 in for x and getting the upper limit. Then you could substitute those numbers directly in for u. But let's just play it safe, and let's say that we got to go substitute 2x back in. So this is going to be 2 times 1 plus 1, and this is going to be e to the 2 times 0 plus 1. And then that's going to be 1/2 e to the power of 3 minus 1/2 e to the power of 1. Or you can take out a 1/2 e and e squared minus 1. Okay, so I'm going to save this answer. I'm actually going to do it the other way, like I kind of mentioned. It's a little bit confusing, but I'm going to do the other method by changing these limits of integration. So if you get to this right here, you actually, for a definite integral, you do not have to substitute u back in if you change the limits of the integration. So for example, instead of 0 and 1, I'm going to, now 2x plus 1 becomes u, so 2 times 1 plus 1 equals 3. So this upper limit of 1 actually becomes 3 now. And this 0 here goes in for x, and that's 2 times 0 plus 1, which is 1. So the lower limit, instead of 0, is actually 1. Then you can go straight from here, and you can go e to the 3 minus 1/2 e to the 1. And so that will save you a little bit of time, too, if you want. But my first time through it, I kind of mixed up the two there and kind of forgot to change the limits here. So this is the way that I was thinking of doing it, but I forgot to change the limits of integration. So here's another example, one more final example here where we have a definite integral. Okay, so you want to pick your u, right, as 1 plus 5x. Du then becomes 5 dx. We have a 1 dx, so if you want to make this a 5 dx, you have to put a 1 over 5 over here. And so we have this 1 over 1, sorry, let's see, put the u in there. So 1 over u to the power of 4 du. And we'll put our 1/5 there as well. Now, just like in the other example here, we're going to integrate, but you have to be careful with this limits of integration here, okay? If you leave them as 0 and 2, you have to make sure that you substitute this back in. Okay, so this is the error that I made in the last question. So if we integrate this, well, actually, let's rewrite this to make it a bit easier. 0 and 2. This is going to be u to the negative 4. Why don't we do that instead? So this is 1/5. This is going to be u to the negative 3. And we're going to 1 over negative 3, which becomes 1 over negative 15 times 1 plus 5x to the power of negative 3. And we are going to integrate that, and we can use the same limits of integration, 0 to 2. So if we substitute in 2 here, we get 1 plus 10 to the power of negative 3, and minus 1 over negative 15 times 1 plus 0 to the negative 3. And we simplify this. Okay, so when this is evaluated here, this is your answer. Simplified fraction, 266 over 3993. I had to make a little correction.
Okay.
That should be your answer for that indefinite integral.